In the middle of the 19th century, before modern chemistry was established, a number of scientists experimenting with materials came to understand that matter was made up of different elements. They found that some elements were very similar, while others were radically different. What they could not understand was why these differences existed. Solving this mystery led to the development of the periodic table of the elements, which remains the major analytical tool of chemistry. Ancient metalworkers were perhaps the first to learn about the elements. Gold, silver, copper, and iron were forged in foundries as long ago as ancient times. By 1800, some 30 elements were known, and over the next 100 years, over 60 elements had been identified. As they studied these elements, scientists looked for patterns and how the different elements related together. In 1869, a Russian chemist, Dimitri Mendeleev, published this table of all the known elements. It is the forerunner of the periodic table we use today, and one of the most brilliant insights of science. Mendeleev's table was based on the increasing atomic mass of the elements. As he arranged the elements in his table, he found that some had similar properties. Those he arranged in vertical columns in his table. He also recognized that there were gaps in the patterns of the elements, and predicted that there were undiscovered elements that must fill those gaps. Later, new elements were discovered that fit his predictions. Today, we do not list the elements in the periodic table by their atomic mass. We list them by atomic number. The number of protons in the nucleus of the atom determines the atomic number of an element. The person who saw the importance of atomic number was a young English scientist by the name of Henry Moseley. He was a student of Ernest Rutherford, who had discovered the nucleus and gave a preliminary explanation of the atomic structure. Moseley understood that the significant difference between the elements was their number of protons. Once the number of protons is known, it is possible to determine the number of electrons in a neutral atom. It was not that Mendeleev was wrong in the way that he listed the elements. The atomic mass of elements increases as the number of protons in the nucleus increases, but atomic number tells us more about the element. The periodic law is the basis of the periodic table. It states, when elements are arranged in order of increasing atomic number, their physical and chemical properties show a periodic pattern. As we will see, the pattern of the table is tied to the very structure of the atom itself. That is what makes it such a useful tool.